Hello, we're now on question 3. We have to compute the volume of a solid formed by the region bounded by the graphs y equals sine of x and y equals cosine of x between when x is between 0 and pi over 4, rotated about the y equals minus 2 axis down here. As you can see, I've drawn cosine of x in green and sine of x in red. We have to get the region between them shown in this green slashes right here. However, we have to be careful and make note that we don't rotate about y equals 0. We have to rotate down here. So, to begin, we have to recall that volume equals the integral of the area that we see. We also have to recall that area of a circle equals pi r squared. Now, this is a little bit different because we are working with two different graphs. So, and we're only getting part of that area. To know what that area is, we have to subtract one area of the graph from the other. This here green represents cosine, and this red represents sine. Granted, this isn't exactly because we are going about y minus 2, so there would be a hole inside of these two, but for now we can just think of it like this. And we have to subtract another circle's area. Okay? So, I'm going to make this one a capital R so that we can tell that this one is the outer radius, this green, subtracted by the smaller radius, which is this red area. So let me pull out this pi, capital R squared minus r squared, the radius. Now, finding the radius, we can see that cosine is on the outside because it's on top here, and when you do it about the axis, it's on the outside. However, we can't just put cosine because this is being rotated about y equals negative 2. It is 2 units from that axis, so the actual radius of this on the outside is cosine of x plus 2, because it's 2 units from it going up. So that one is r squared, this capital R squared. And this smaller r squared is sine. But again, just like cosine is, sine is 2 units from that line. So we have to do sine x plus 2. So this is our small radius, this is r. This is our larger radius, capital R. So now that we have this set up, we have to integrate this because this is our ax right here. So, first things first, I'm going to bring out this pi and I'm going to FOIL capital R and lowercase r. And I'm going to do that all in one step. So we have pi, it's on the outside now. There's the integral, so we would have cosine squared x plus, it would be 4 cosine x plus 4. And then this over here is the exact same format, just replace cosines with sines. And because all these are being added, and all this is being subtracted, we have to change our signs. So this would be sine squared x minus 4 sine x minus 4. So here we can see that we can cancel out this plus 4 and this minus 4. That would be 0. And I'm going to rearrange it a little bit. Pi, again on the outside, integral cosine squared x minus sine squared x. We have a plus cosine. We have a minus 4 sine x. Okay. So, we can almost integrate this. Almost. What I'm going to do is I'm going to reduce these two terms' powers. We can do that with using the formula for cosine. It would be 1 plus cosine 2x. And this is all over 2, but I'm going to separate these two terms like that. And then for this one right here, for sine, it would be 1 minus cosine 2x. But you have to be careful because this is already being subtracted, so you have to distribute that sign into the 1 and to this minus cosine. That would make this plus cosine 2x. And again, I'm going to separate the over 2, because hear me out, we're going to do something cool with that here in a second. And then just rewrite these two. Plus cosine x, or plus 4 cosine x minus 4 sine x. Again, this is a dx right here, my bad. This is being integrated and then multiplied by pi. So I separated these two because you can automatically, just like with our 4's here, you can cancel out this minus half and this positive half. And because these are both cosine 2x over 2, you can add them up and it would be just cosine 2x because these are both halves. So that those would be combined and it would just be cosine 2x. So I'm going to rewrite it one last time on the bottom. Pi times the integral cosine 2x plus 4 cosine x minus 4 sine x dx. And I will be back here in a second. I will rewrite this on the top and erase all of this that we don't really need anymore. So when we plug in everything, for now I'm going to leave the pi out. When we plug in pi over 4 into sine 2x, we have 2 pi over 4. That equals pi over 2. Sine of pi over 2, if you recall from our unit circle, equals 1. So this value up here is 1. This is being over 2. So this first value is 1 over 2. We're adding next. Sine of pi over 4 is root 2 over 2. It is being multiplied by 4. That means that we can cancel this, simplify this into 2 root 2. I'm going to move this over. Cosine of x is at the same point, meaning that it will also equal root 2 over 2, and then with the 4 would equal another 2 root 2. We can see this by on our graph, they meet there, that's the same exact point. And this is being subtracted by when you plug in 0. So when you plug in 0 into here, you get sine of 0. Sine of 0 is 0. 0 over 2 is 0. Minus, and we keep on going. Again, sine of 0 is 0. 0 times 4 is 0. Cosine of 0 is 1. 1 times 4 is 4. And we're doing subtracting now. It'll be minus 4. So, and this is all being multiplied by pi. So when you combine like terms, you would get 4 root 2, because you're combining these two things, and then you'd get minus, this would be, you'd get minus 3.5. If you want to put that into a fraction, it would be 7 over 2. And again, this is all being multiplied by pi. So this, pardon me erasing some of this stuff, this is your final answer. Pi times 4 root 2 minus 7 over 2. That is the area, and that is the volume of the solid when this area is rotated about y equals minus 2. And we are back. All I did was move what we had here on the bottom all the way up here so that we have more space that we can work with. Now that we have everything in one term, nothing's being multiplied with each other. Granted, the 4s are perfectly fine. Now we can integrate nice and smoothly. So I'm going to begin that integration right now. So one thing that I do personally when working with trig is I like to draw this thing on the bottom right here. We have sine, cosine, minus cosine, and then back to sine. When we derive it, we read this list going down. Sine turns into cosine, cosine minus sine, we go this way. When we integrate, we work backwards and we go upwards. So from cosine we get sine, minus sine we get cosine. I enjoy that, and I've heard that it helps others, so I hope that you can use that too. And we will use it here exactly. So when we go from cosine, we go to sine. So this is sine 2x. Because there's a 2 inside, we have to divide by that coefficient as well, especially because we were working backwards. Plus, what's our next term? 4. The 4 will stay there. Cosine of x. So again, we look back here, from cosine, we go to sine, because we were doing this thing, method. Sine of x. And then we have minus 4, so we have sine of x. This part is a little bit tricky, because we have a minus sign right here. And this sine of x goes to minus cosine of x. So we'll have minus cosine of x, but instead of doing that, we just make this to a plus. Plus 4 cosine x. And recall, and I haven't been writing them, but our bounds, by the way, are from 0 to pi over 4. Keep that in mind. So now that we have this, we just have to plug in our answers.